Good afternoon, students. Today we'll learn about to do integration by partial fraction. Okay, so class 12th. The most important topic we have integrals. So here we'll try integration by partial fraction. Integration by partial fractions. So now we'll try to see how we can apply the partial fraction. For this, we'll write first the function should be in the form of rational form. Okay, form of rational form. Now, like first one we have px plus q upon x minus a x minus b, where a is not equal to p. Okay, so now we'll write here the form of partial fraction. Okay, form of partial fraction here. So what will be? It will be a upon x minus a plus b upon x minus b. Okay. The next form will be plus q upon x minus a whole square. Okay. So now what its form will be a upon x minus a plus b upon x minus b whole square. Okay. So it will be px square plus qx plus r upon x minus a, x minus b and x minus c. Okay. So we'll have here a upon x minus a plus b upon x minus b plus c upon x minus c. Okay. We'll move to the fourth one, that is px square plus qx plus r upon x minus a whole square x minus b. This is the fourth one we have. It will be a upon x minus a plus b upon x minus b whole square. No, it will be a plus c upon x minus b. Okay. And the last I have, that is px square plus qx plus r upon x minus a x square plus bx plus c. So we'll have this a upon x minus a plus bx plus c upon x square plus bx plus c, and where we can write this, thus this cannot be factorized further. Okay, cannot be factorized further. So now we'll try integration by partial fractions. So for this, if the function is in this rational form, then we can apply the partial fraction like this. So now we'll try numerical and try to see one by one all these forms. Let us be learned today. Okay, so now let us try to solve numericals on these types of rational forms. Let us see how we can apply the formula. Now we have the form x upon x plus 1 x plus 2 with respect to ds. This is given. Now how we can solve? Let us apply this question is given in the simple rational form. Now we need to apply the partial fraction form. Let us how? X is equal to a upon x plus 1. Here I will apply x plus 1 x plus 2. Okay, so now plus b upon x plus 2. So we'll have x is equal to a x plus 2 plus b x plus 1. But how? I have taken the LCM here, and by after taking the LCM I have cancelled out the denominator. So we have everything in the numerator only. So now we'll compare and we'll get 1. 2a plus b is equal to 0. Okay, so now we have two equations. Let us solve them. What I will get if I subtract? We have already learned how to solve equations in class 10th using different methods. Okay, now in this class we'll try to apply them. So what I got here is 1. So I got a is equal to minus 1 and b is equal to, if I put this value here minus 1, then it will go 2. So I will got 2 here, minus 1 plus 1, because here it is in the subtraction form. So on the right hand side it will be in the addition form. So 1 plus 1, 2. So I got a minus 1 b 2. So let us now apply minus 1 upon x plus 1 plus b, we have 2. So we'll have this. We'll have this. So now let us integrate them. So I will get the value here minus log x plus 1 plus 2 log x plus 2. What else I can do here? Minus log x plus 1 plus log x plus 2 whole square. Okay, so this plus c. Okay, that is how we able to apply the formula. Okay, so that is now log a plus log b into log a log b, log a minus log b. So I can apply log whole square upon x plus 1 plus c. Okay, so that is how we can apply and solve the numerical by integrate the numerical by partial fraction. Okay, so let us try to solve more numericals now. Let us see how we can apply now. Now we have, that is 1 upon x square minus 9. Okay, so let us see how we can apply the form. We have x minus 3 x plus 3. Okay, so now we'll try. 1 is equal to a upon x minus 3 plus b upon x plus 3. Okay, so now we'll try to see how we can solve. Now 1 is equal to a x plus 3 plus b x minus 3. So now what will happen? Now we can take a plus b is equal to 0 and 3a minus 3b is equal to 1. Okay, so now we can solve the equations. How? What we can do here? Multiply this equation by 3. So what will happen? 3a plus 3b is equal to 0. Okay, 3a minus 3b is equal to 1. Adding what we get here? 1. got 6a is equal to 1. So I got a is equal to 1 upon 6. Okay, now I got a is equal to 1 upon 6. Putting in this, we find b is equal to minus 1 upon 6. Okay, so that is how we able to find the value for a and b. Now let us put here and try to integrate. What I will get, 1 upon 6 upon 6. I'll have x minus 3, where minus 1 upon 6 we have x plus 3. So what, 1 upon 6 log x minus 3. When we integrate this, I got 1 upon 6 log x plus 3. Okay, so that is how we can easily find the value now. Okay, I can write here, that is b is equal to minus 1 upon 6. Now what happens, 1 upon 6 if I take common, so after taking common here, 1 upon 6, what I can do here, I can write log x minus 3 upon x plus 3 plus c. Okay, so that is how we can easily solve numerical. Okay, so that is how we solve the numerical. We can say solving the numerical, or we can say finding the integral of a function using partial fraction. So now let us try the next numerical. Let us try to solve the next numerical we have. Let us see how we can use this partial fraction now. So now we have the question in my hand, that is 3x minus 1 upon x minus 1, x minus 2, x minus 3 dx. Now they have given this. Now let us see how we can apply such kind of. Now let us see how we can solve x minus 1, x minus 2, x minus 3. We'll have here a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. So now I will left with this, that is a x minus 2 x minus 3 plus b x minus 1 x minus 3 plus c x minus 1 x minus 2. Okay, so now what we can do, just multiply it. X square minus 3x minus 2x plus 6 plus b x square minus 3x minus x plus 3 plus c x square minus 2x minus x plus 2. So I have got this a x square minus 5x plus 6 plus b, I have x square minus 4x plus 3 plus c x square minus 3x plus 2. Okay, now what we can do here, let's compare with it. So I got a plus b plus c is equal to 0, minus 5a minus 4b minus 3c is equal to 3, and 6a plus 3b plus 2c is equal to minus 1. Okay, now let us try to solve two equations. Okay, now we have a plus b plus c is equal to 0, minus 5a minus 5b, okay, minus 5a minus 5b minus 4b minus 3c is equal to 3. Okay, now what we can do here, we can use these two equations. Now we have first, second and third. Okay, now we have a plus b plus c is equal to 0. Okay, now we can multiply 5 here. So I got 5a plus 5b plus 5c is equal to 0, minus 5a minus 4b minus 3c is equal to 0. So what I got here, eliminate this. No, here it is 3. So what I will got here, b plus 2c is equal to 3. So this is my fourth equation. Okay, what else I can do? Multiply 6 here. So I got here 6a plus 6b plus 6c, and here 6a plus 3b plus 2c is equal to minus 1 here and 0 here. Subtract. What you will got here, 3b plus 4c is equal to 1. Okay, so now I got two equations here. Fifth one. Okay, now I got two equations here. Now let us try to solve them. I'll solve it here. B plus 2c is equal to 3 and 3b plus 4c is equal to 1. What I can do here? Multiply with 3. What I will got? 3b plus 6c is equal to 9. 3b plus 4c is equal to 1. Subtract it. I got 2c is equal to 8. So I got c is equal to 4. C is equal to 4. Put this value here. So c is 4. 4 into 4, 16. Okay. Now 4 into 4, 16. 3b is equal to 1 minus 16, that is equal to minus 15. So therefore c is equal to minus 5. So I got both the values. B I got here. I got my value here C 4 and B I got minus 5. Okay, so here I got B. So after getting B here and C here, I can put it here so that I can find the value of A. So what is B? Minus 5. So here if I put minus 5 plus 4 is equal to 0. But here we have A also minus 5. So what I got? A minus 1 is equal to 0. But A is equal to 1. Okay. Now let us try to put this value here. Okay. So that we can easily solve this numerical. Now I got A is 1. So I got dx upon x minus 1. Now what is B? Minus 5. Let's take it outside. X minus 2 plus what is C here? 4. Take outside. I got this. So now I can easily solve them. I will got here log x minus 1 minus 5 log x minus 2 plus 4 log x minus 3 plus C. Okay, so that is how we able to solve the integration by partial fraction. I have tried to solve the 3 forms. Now I am left with the 2 forms. Okay, so now we'll try to solve more. Now let us try to solve more numericals based on this. So now I have one more question in my hand, that is x square plus 1 x square plus 2 upon x square plus 3 and x square plus 4. So now we'll solve this numerical. I can write this like this. X square plus 3 x square plus 4. Okay, now we'll try to solve this first, because if I multiply this here and subtract, we got this value. Okay, so now let us try to solve 4x plus 10 upon x square plus 3 x square plus 4 is equal to ax plus b x square plus 3 plus cx plus d upon x square plus 4. Okay, now let us try to solve it out. We got ax plus b, we'll write here 4x plus 10. Okay, so now we'll try to sort it out is plus cx plus d x square plus 3. Okay, so this I can write like this form, 4x plus 10 upon this. And now I will first integrate it by using the partial fraction form, because we know the integration one is x, so I can put it in later. Now what if I compare, if I see what I got here, ax cube plus 4ax plus bx square plus cx cube plus 3cx plus dx square plus 3d. Now if I see a plus c is equal to 0, okay, and if I go for square, b plus d is equal to 0. Okay, now if I go for x, so we have 4a plus 3c, 4a plus 3c, wait, cx is cube here, then 3cx plus dx square plus 3d. Okay, so I got 4a plus 3c is equal to 4, and if I go for constant term here, that is only one term is constant, I think. No, wait. Here ax cube plus 4ax plus bx square. Oh, I missed one, 4b here. Okay, so I got 4b plus, here also if I multiply, okay, 3cx plus dx square plus 3d, 3d is equal to 10. Okay, 3d is equal to 10. Now what I can do here, use these two equations. So I have first, second, third and fourth equation here. Okay, so now what will be its solution here? What we'll do, we'll multiply with 4, second equation. So I got 4b plus 4d is equal to 0, 4b plus 3d is equal to 10. So what I got here is d is equal to minus 10. So b will be, therefore b will be 10. So I got two values here, b and d. Now after getting b and d, what we can do here, we need to find, we can take these two equations now, first and third, multiply first by 4. So I got 4a plus 4c is equal to 0, 4a plus 3c is equal to 4. So after subtracting, I got c is equal to minus 4. So I got bcd. Now therefore c will be 4. So that is how we find the values. Now we'll try to integrate this. So I will got, what is a here? I've just found a. Now I don't, c is minus 4. So a will be 4. No? So now I can put values here. 4 into x plus, what is b here? 10. Okay, upon x square plus 3 plus, if I solve this, I got cx plus d. What is c here? Minus 4. Okay, minus 4 we have, and x plus d we have minus 10. So now I got this. Okay. Now we have find the values here, that the values which I found here is, that is d is equal to 6, b minus 2, c 0 and a 4. So now we'll try to put the values in this. So what will happen, you see here we have a and we have c, that is 0. Okay, so now we can cancel out a and c. We'll take now only b. What is b? We have minus 2. So we have dx upon x square plus 3. And what we have d here? 6. So we'll take 6 dx upon x square plus 4. Okay. So now we'll integrate these to get our answer. We'll put here one minus here. So now we can put 1 minus. So it will be plus 2 dx upon x square plus 3, but here it will be minus 6 dx upon x square plus 4. Okay, so likewise we'll try to solve the answer here. Okay, so we find a value here. So now let us try to integrate this so that I can get this value now, dx. So let us try to solve here. So now I will take this step here. So I will got x here, my plus 2 here. Now here we will apply the formula for that. We will write here dx x square plus root 3 whole square. Okay, minus 6 dx, we have x square plus 2 whole square. Okay, so we'll try to write the formulas which we have learned in the previous exercise about, that is integration of, that is dx upon x square plus a square. So I got 1 upon a tan inverse 1 upon a, that is root 3. So we'll have tan inverse x square plus a square, we have the x upon a. So root 3 here plus, so sorry, minus we have 6. Now same here, x square plus a square, so 0.2, and we'll write tan inverse x upon 2 plus c. So that is how we able to solve the numerical. We can also now we can reduce it. So I got x plus 2 upon root 3 tan inverse x upon root 3 minus 3 tan inverse x upon 2 plus c. Okay, so that is how we able to solve the integration by partial fraction. Now we'll solve more numericals based on partial fraction in integral chapter for class 12th. Now I have a question, that is 1 upon ex minus 1 dx. Okay, so now we'll try to solve such kind of numerical. Now we'll have, that is how to use it. Put e raised power x is equal to e raised power x minus 1 is equal to t, so that ex dx is equal to dt. So dx will be dt upon ex will be dt. Okay, put like this, put ex equal to t, so we will have t. Okay, so now we'll try to solve it out like this. We'll have t into t minus 1. Now let us see how we can do it. T plus b upon t minus 1. So now 1 is equal to a t minus 1 plus bt. Okay, so now I will got here this. What we will do here now? Very simple. Now compare a plus b is equal to 0 and minus a is equal to 1, that is a is equal to minus 1. So therefore b will be, we will put a value of a in this, so we'll get minus 1 plus b is equal to 0, so b is equal to 1. So now we'll try to put in this, so I will get here minus dt upon t plus dt upon t minus 1. So now I will got minus log t plus log t minus 1, or I can put like this, log t minus 1 upon t. So likewise we can easily solve the numerical based on partial fraction. Now we'll solve the next numerical. Okay, so now we'll try to solve next numerical based on partial fraction. Let us find the integral of a function using partial fraction. Now we have next question, that is cos x upon 1 minus sin x, and we have 2 minus sin x. Okay, so now what we can do here, let's try to sort it out. What we can do, put sin x is equal to t, so that cos x dx is equal to dt. So what I got here, dt upon 1 minus t, 2 minus t. So now what we can do here, we can put 1 minus t plus b upon 2 minus t. So now comparing, I got 2 minus t plus 3 1 minus t. So now 2a plus b is equal to 1 and minus a minus b is equal to 0. That means a plus b is equal to 0. Okay, so now I got this first equation, second equation. Okay, now let us try to solve. We can multiply 2, okay, in the second equation. So I got here 2a plus b is equal to 1, 2a plus 2b is equal to 0. So now reduce this, I got minus b is equal to 1. So therefore I got the value of b is equal to minus 1. I can put in this also, a minus 1 is equal to 0, so therefore a is equal to 1. Okay, so now I find the value both of a and b. We'll try to put here dt upon 1 minus t plus, what is b here, b is what b we have minus 1, so it will be minus dt upon 2 minus t. So I got log 1 minus t minus log 2 minus t. So finally I got my answer, that is log 1 minus t upon 2 minus t plus c. Okay, so that is how we able to solve numerical on based on partial fraction. Okay, so now we'll try to solve the another numerical in finding the integral using partial fraction. Okay, so let us see what we have now. Is a very simple question, that is they have given dx upon x xn plus 1. We have this. Now what we need to do is we need to multiply by xn minus 1 in numerator and denominator. So what we'll get here, n minus 1 here, if I multiply xn minus 1 into xn plus 1, okay, so I got this. What I will get here, upon we have xn plus 1, okay, dx. Now what we can do? Put xn minus 1 is equal to t. Now I will put this xn is equal to t, so that xn minus 1 dx is equal to dt. So now we'll have this dt, 1 upon n will be outside, upon t plus 1. Okay, so now I can put the value here, a upon t plus b upon t plus 1. So now I got a t plus 1 plus b t. So I got a plus b is equal to 0 and a is equal to 1. So therefore b is equal to minus 1. Okay, so now let us try to solve this. That is, a we have 1. So we'll put here dt upon t plus we have b upon t plus 1. So now it will look like that dt upon t plus 1. So we'll put here t plus 1. Okay, so now I got it, that is log t minus log t plus 1 plus c. So that is how we can solve such kind of numerical. Now put the value of t here. What is t? xn minus log xn plus 1 plus c. So I got this value log xn upon xn plus 1 plus c. Okay, so we can solve such kind of numerical using we need to find the integral. Okay, so we need to find the integral of such kind of particular functions using partial fraction.